Thank you so much for the feedback, sir.
Looking
Um,
forward.
good Good day, everyone. I am Jennifer Villarreño from Southern Leyte State University, Philippines. And on behalf of my co-authors, I have the honor to present to you our paper entitled Detection of Poultry Diseases Using Convolutional Neural Networks, a Fecal Image-Based Approach. So, poultry farming is one of the fastest growing sectors of livestock production worldwide, with global poultry meat production exceeding 103.5 million metric tons in 2023 and is projected to be 104.2 metric tons million metric tons in 2024. And with these data, it is evident that this industry is playing vital role in generating income and supporting livelihoods for producers and um, farmers. Globally, poultry diseases remain a major issue for this industry, and the occurrence and reoccurrences of these diseases will continue to threaten its strategic future. Controlling and monitoring poultry diseases such as coccidiosis, Newcastle disease, avian influenza, and salmonella um, is we need to control this one because it really affects the poultry and it may also pose a significant public health to the community. And traditional diagnostic methods for identifying infections on these poultries involve visual observations and sound distinctions. And these approach are quite subjective. Thus, we need to automate this process in using machine learning and other algorithms to, to avoid biasness in decision making. And also, it when dealing with large scale production and monitoring of poultry, it requires labor intensive laboratory testing, which can be costly, slow, and difficult to access in rural or resource constrained areas. Thus, in an effort to mitigate these challenges, this study examines the potential use of the convolutional neural networks in identifying poultry diseases using fecal images. For the conceptual framework of the study, we followed this framework, the input process output. So the input of this study will be the images, the chicken fecal images, and then it will be used to train the model using CNN. And with the generated model, it will now be utilized and be integrated into an application for automatic detection of diseases based on their fecal images. This study utilized poultry fecal images, and we have downloaded these data from kaggle.com. And originally, the data for the Newcastle disease is only 562. Thus, we applied data augmentation to propagate this data set. Um, Basically, we apply data augmentation like rotating the image 30 degrees repeatedly to populate the data and to generate out from 562 we have generated a total of 2,448 Newcastle images, thus making it total of overall we have 8,683 images for both the training, validation, and the testing sample. And by the way, for the distribution of data set, we have utilized 80%, 10%, 80% for training, 10% for validation, and 10% for the testing. And these are the sample images for each of the class for coccidiosis, Newcastle, salmonellosis, and then healthy. And we can see that there are differences in terms of the characteristic. For coccidiosis, it's somewhat yellowish. For Newcastle, there is a green spots in the fecal. And then for salmonella, the presence of salmonella, there is a like whitish part of the fecal, and then for healthy one, just the normal fecal feature for a poultry. And for the design of our CNN, we configure it to have like layers, four layers, namely 32, 64, 128, and 128 at different depths. And these convolution layers are responsible for extracting features from these images, and such as shapes, the textures, the fineness details, and other important features that will determine each of these class. And then after the feature extraction using the convolution pooling layers, um, it is being fed into a feed forward um, algorithm, so which is responsible for mapping out these features to its specific class, and with four output nodes representing the four different classes, which is comprising the three diseases and one healthy classification. And the model is also being evaluated using the following performance matrix. The common one, the usual one, which is the, of course, accuracy, the precision, the recall, the specificity, and then the F1 score. Then, once the model has been evaluated and enough accuracy rate has been attained, then it will now be loaded into an application. So for the application development, we have utilized the following softwares and um, libraries. So we have Keras, Pandas, NumPy, Matplotlib, Google Colab, Google Drive, the Streamlit for the application development, together with the GitHub. And these are the results of our study. Um, The model was trained using 500 epochs using the 6,949 labeled chicken images with the dimensions of 128 by 128 to indicate the presence or the absence of the particular disease. The highest training accuracy was observed at 418 epoch, and obtaining an accuracy rate of 99.79%. And also um, a validation accuracy of 98.69%. A model loss is also being plotted, and we have achieved a model loss of 0.009 for the training model and 0.0767 for the validation model, which indicates that we have very loss value, which indicates that the model is learning with the data being provided it during the training process. And this is the confusion matrix showing the results of the classification based on the testing data. And based on this confusion matrix heat map, it can be observed that the model is good in classifying the diseases of poultry based on the fecal images, as the dark colors are being observed along the diagonal, which means that that the model is correctly classifying the instances of these samples. The model correctly classified 209 instances of coccidiosis, but misclassified one. And for the high number of misclassification, it is observed with the salmonella and healthy. Maybe because there are some instances wherein the healthy images also contain whitish part, which is also present in data sets for salmonella. But overall, the accuracy rate of the model using the testing sample is 98.04%. And this table is providing a detailed evaluation of the model's performance per class. The matrix for the precision, recall, specificity, and F1 score is calculated to assess the model's accuracy rate. And overall, the model exhibits strong performance with high values in most of the matrix. And there's a slight decrease, as we can observe in the recall for salmonella, because as I have said a while ago, maybe because it is likely due to the similarity between the salmonella and the healthy instances. Additionally, the relatively low precision for healthy suggests that the model might sometimes misclassify instances of healthy as with salmonella um, disease. And since, as we can observe from this performance evaluation, the model is good in classifying these instances of poultry diseases and the absence of these poultry diseases as being represented by the healthy images, the model is now being deployed into the app, this one. So this app is just a simple app for for testing the model. It is requiring the user to upload an image, and then based on the uploaded image, it will be classifying the image accordingly, referring to the different diseases of the poultry being presented a while ago, and whether the given image is healthy or not. For the conclusion, the CNN model trained on 6,949 labeled chicken fecal images over 500 epochs exhibit a high rating and validation accuracy rate of 99.73% with a loss value of 0.0099 and 0.0767 um, accordingly by epoch 418. So this is an indication that the model is doing well in classifying the instances of these diseases. And also with the performance matrix such as the precision, recall, F1 score, and specificity, it is remained consistently high with values 98.11%, 98.04%, 100%, and 98.05% respectively, demonstrating the model's reliability on detecting poultry diseases. Further development that we can explore with this study is the integration of this model to uh, wider scale monitoring of poultry diseases in like in a farm or in um, in a company where it can be deployed. I think this will be all for my presentation. Thank you so much for your attention. Have a nice day, everyone.
Thank you, Jenny. Thank you. Very informative. Thank you very much. Any questions?
I have one question. Have you compare your approach with your model with other models? Thank you.
Pardon, sir.
Have you compare your approach with your model with other models,
Oh, yeah.
other different models?
With the I conducted a literature review about this study, and other studies they have also utilized with a CNN model, but in terms of the hyperparameters, I have adjusted the hyperparameters of this CNN model so that it somehow exceed the accuracy rate of the previous study related to this study, sir.
Thank you.
Thank you, Alexander. Any other questions?
Yes, I have one. Do do you plan? Do you have results of your model on not statical pictures, but in dynamic? I mean, for example, for videos.
We haven't tried it yet, sir, but that will be a future development for this study. Um, Maybe we can use YOLO to apply object detection and also classification model using videos and not static inputs for the model, sir.
Okay, thank you.
And we will be furthering this study because actually the next step of this study is um, to create an application which can be now utilized in the farm using different cameras, focusing on the fecal images of the chicken or poultry in the farm that we have already um, consulted.
Okay, thank you very much.
Other questions? Okay, thank you very much, Jenny. Thank you.
Thank you so much, everyone.